Earlier this month, a demonstrator aircraft for what could be the first new civil supersonic plane to be launched since the 1960s took to the skies. It's a milestone moment in the highly anticipated new era of supersonic travel. The XB-1, a technology demonstrator aircraft built by Colorado-based Boom Supersonic, successfully completed its first test flight at the Mojave Air and Spaceport in California. It was announced March 22nd. The XB-1 is the world's first independently developed supersonic jet and paves the way for the development of Boom's commercial plane Overture. The hard part is over. I very much believe in the return of supersonic air travel, and ultimately to bring it to every passenger on every route. And that's not something that takes place overnight, says Scholl. The hard part of building a supersonic jet is making something that's so sleek and so slippery take off and land safely. Aerodynamics, materials, propulsion. There have been only two civil supersonic planes, the Soviet Tupolev Tu-144 and the British-French Concorde, which flew for the last time in October 2003, more than 2 decades ago. Now the industry is abuzz with supersonic and hypersonic projects, from NASA and Lockheed Martin's quiet X-59 aircraft, which limits sonic boom, to Atlanta-based Hermeus, which this week unveiled its first flyable aircraft. The advent of digital engineering is a huge enabler for why supersonic flight's coming back, explains Scholl. Aerodynamics, materials, propulsion. Those are the big 3 areas where we've made huge progress versus Concorde. Computational fluid dynamics has revolutionized the way aircraft are designed. Back in the 1960s, Concorde was developed in wind tunnels, which meant building costly physical models, running tests, then repeat. You just can't test very many designs, when every iteration costs millions and takes months, explains Scholl. But Boom has perfected its aircraft's efficient, aerodynamic design using computational fluid dynamics, which is basically a digital wind tunnel. We can run the equivalent of hundreds of wind tunnel tests overnight in simulation for a fraction of the cost of a real wind tunnel test. Augmented reality vision system has added a new dimension to aircraft design. Concorde famously reduced drag when reaching supersonic speeds by having a long, pointed nose on a hinge that tilted forward when taking off, landing and taxiing so the pilots could see the runway. Today we have this amazing thing called a camera and a screen, says Scholl with a smile, when explaining XB-1's unique augmented reality vision system. Rather than needing a complex movable nose and windscreen views, the craft instead makes use of 2 nose-mounted cameras, digitally augmented with altitude and flight path indications. It's far better than the view ever was on Concorde, claims Scholl, and the augmented reality symbology will help pilots line up the target and achieve a beautiful landing every time. Fueled by SAF poses an interesting question for the future of aviation. So, with the aviation industry having a target to reach net zero carbon emissions by 2050, where does a supersonic plane whizzing around at twice the speed of modern conventional jets fit into all this? Overture is designed to be powered by conventional jet engines and to run on up to 100% sustainable aviation fuel, SAF. There's not enough of it and it costs too much, but it is scaling, says Scholl, but he reckons that one day it'll be used for all long-haul air travel. It's the future of aviation, he declares. The need for speed. Scholl concedes that flying faster is inherently more energy-intensive, but argues that we shouldn't have to choose between climate-friendly and passenger-friendly. In fact, we can accelerate the transition towards lower carbon transportation by making sure that the most desirable airplane is also the most climate-friendly. He compares today's transatlantic air travel to driving across the Atlantic in a not very good SUV. Aboard Overture, driving across the Atlantic is going to be like driving a Tesla across it. And yeah, it's going to be more energy-intensive, but from a climate perspective, it doesn't matter because the energy source is green. If we have faster airplanes, we don't need as many. A faster airplane is much more human efficient, and it's much more capital efficient. You can do more flights with the same airplane and crew, says Scholl. We can significantly reduce all of the cost and impact that goes into airplanes by making them faster. If we have faster airplanes, we don't need as many. The reason we don't use propeller flights between London and New York, he says, is that while it might be less energy intensive than a jet engine, it would be more expensive and more impactful overall, because going at half the speed you would need way more. Anywhere in the world in 4 hours for $100. According to sources, his dream was for people to one day be able to fly anywhere in the world in 4 hours. 3 years later, he says it's still his North Star. If you look back at Concorde, built out of 1960s technology, this was like a 20,000 quid ticket, and it just wasn't attainable, says Scholl. On the first iteration of Boom's Overture plane, dubbed Overture 1, our goal is to cut that by a factor of 4 and be able to have supersonic flight available to the tens of millions of people who can fly business class today. The long-term vision is for later versions of Overture. There's plans for Overture 2, then Overture 3 will bring supersonic flights on more routes to more passengers at lower costs. Boom's goal is to cut flights to half the time or less than it takes today. The ultimate goal is flights that are faster, more affordable, more convenient, more sustainable. And we're just going to keep working on that until we can travel effortlessly around the planet. 2024 is one of the biggest years yet. Boom aims to carry its first passengers on Overture, between 64 and 80 of them, at Mach 1.7 before the end of the decade. Presently, it boasts an order book of 130 orders and pre-orders from customers including American Airlines, United Airlines, and Japan Airlines.